everyone, welcome to Vedantu JEE English. I am Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you so that we can start with today's session. Very good evening students, very good evening. So general organic chemistry, it's about the effects, right? So inductive effect, hyperconjugation effect, resonance effect, right? Then we are going to discuss aromaticity. Then we are going to discuss stability of intermediates based on this, right? So all these things, how it is used in reaction part, that you all know. If a carbocation is formed, then you should know stability of carbocation. If the intermediate is carbon ion, you should know the stability of carbon ion. If a free radical is formed, you should know how to understand how to predict the stability of free radical, right? What are the different intermediates that are possible? So all these things we are going to discuss in this particular chapter, and today we are going to do inductive effect, right? Inductive effect. So are you all ready for that, right? Because it's going to be a very interesting session, students. In inductive effect, right, we will discuss about the basic, from the very basic thing I'll start, then I'll take you to the advanced level of it, right? So if you're like zero in organic chemistry, that will also work, because here I'm to make you hero from zero. Even if you hate organic chemistry, even then you can watch this particular session, but you have to be very regular in all the GOC lectures that I'll be taking here, right? You have to be very regular, okay? Yes, everybody? Okay. So first thing is, has this ever happened with you, right? So when you're drawing these structures of organic chemistry and your mom, who has no idea about like what is this chemistry, like why you're doing this drawing, why you're making these doodles here, right? Go and study. You're like, I was making benzene ring. I was not making any hexagons. I was making benzene ring. It was not cartoonish thing that I was doing, right? I was literally studying, right? So this is what going to happen in the next few lectures, right? We're going to talk about all the structures, and benzene is the king of all, carbon is the king of all, right? So before that, guys, let me remind you about the MVSAT test dates. It is 4th, 5th, 11th and 12th of October, right? Registration is completely free of cost, and all the resources, if you get into 2.5 lakh students, which is possible for you because you're already preparing for JEE, then guys, what you will get here is, you will get one-on-one counseling, you will get 150 crore worth of scholarship. All the courses, everything is 100% free, right? iPhone, iPads, drones, and how you can use AI to understand, to study, right? All these things will be completely free for you, and the interaction, right, with Vedantu's founder will be completely free for you, right? You can interact. If you have an idea, you can represent your idea, you can get the counseling from these top teachers, right, from Vedantu's founders as well. So that will be done only if you register yourself and you give this test. The offline test dates are 4th, 5th, 11th and 12th, where it is going to happen in the nearest Vedantu centers, right? Okay, yes. So about the homework, in last class I gave you the homework. This is the answer, right? And those who have solved it, they will get to know. Yes, carbon is the god of earth, definitely. Yes, carbon is the god. Carbon is everything, because we are made up of carbons, right? Isn't it so? Let's discuss firstly in GOC, right? We'll discuss about electron displacement effect. Electron displacement means the electron is being displaced. For example, you have carbon and carbon, right? Here you don't have any electronegativity difference, so the electrons will lie in the center, right? But here, if you have carbon and halogen, right, then the electrons will lie towards the halogen side. Why? Because halogen is more electronegative, right? So that is actually the displacement of electron, right? Now the electron can also be displaced like this. For example, this is carbon, there is some other, this is halogen, right? And here you have pi bond, and this is automatically, this is shifted here. In that case, you will have Cx and this negative, right? So that means displacement of sigma or pi electron we are going to discuss here. It can be permanent displacement, it can be complete displacement, right? So we'll talk about all of that, right? So partial or complete displacement of sigma or pi electrons, like here we are displacing the sigma electrons, here we are displacing the pi electrons. So in this electron displacement effect, we are talking about all these electrons, right? So based on whether there will be any permanent, now whether there will be permanent displacement or temporary displacement, it is divided into two parts. These electron displacement effects are of two types. One is permanent displacement, other is temporary displacement. So we'll talk about one by one, both of them. So permanent displacement is always present if electronegative atom is present, right? So if you have C and this is X, right? Now this is the pi electrons here, right? So sorry, these are sigma electrons here that are present over here, right? Now this particular displacement is not dependent upon any external factor, right? It means if you are always coming back to your home, it is not dependent upon your friends or anyone. You will always come back to your home only, right? Wherever you go, you will always come back to your home. That is your permanent place, right? Nowhere, no matter you are in, like, you get admission in this or that college, you will always come back to your home, right? That is your permanent place. So permanent displacement does not depend upon the external factors, right? But if you talk about temporary displacement, it depends upon the external reagent. For example, here you have pi bond, and here, because there is no electronegativity effect, like factor contributing here, that's why these electrons will be in the center, because there is no electronegativity difference, right? Now they are very happy, they are chilling, they are in the center, they have, like, you know, friendship with each other. Now suddenly this nucleophile that we'll talk about later in organic chemistry, let's say now you took it as reagent only, this reagent is going to attack over here, right? When this reagent attacks over here, right, then what is going to happen? If this reagent, any reagent is attacking here, that means these electrons are going to jump, right? That means these electrons, it will break the bond here. Let's say this will attack on this carbon and these electrons will jump to this carbon, right? So now what you will see, this is C, and here it is H, here it is H, and here you will have the attachment of Cn. This will be H, this will be H, and this will be negative. Later on you can add H and this will become H, right? Reaction I am not teaching you here. I am not teaching you reaction. I am teaching you that now it depends upon the external reagent. If we don't react this with this reagent, the displacement of electron would not have happened, right? The displacement is happening because of some external factor. When simple cases, there are students who study, they don't need external motivation. They are internally very much motivated, right? That is the permanent displacement. They are like, I know I have this dream and I want to fulfill this dream. For that, what I need to do, I need to study. They don't need to watch any YouTube lecture, they don't need to watch any YouTube motivational video, right? To pump themselves and yes, I'll do that. And after 2 days, their motivation is down. They don't need that. That is permanent because they don't need any external factor. But temporary is when you need external factor. For one time, you will get motivated, then again demotivated, then again motivated, then again demotivated. So that is temporary displacement, right? Okay. Now when we will discuss, first 3 lectures are going to be permanent displacement, that is inductive effect, then mesomeric, then hyperconjugation. Temporary displacement is electromeric and inductomeric effect. Now inductomeric is not in your syllabus. Electromeric also will discuss when we will discuss hyperconjugation effect. Here only we will discuss. This we are going to discuss today and this we are going to discuss tomorrow. This we are going to discuss tomorrow, right? That is our main task, right? So let's start with inductive effect. Inductive effect, right? Now this strength and all that we'll discuss once we have done all the effects, then I'll discuss that why it is so. Why? Right? Because the main agenda is to understand the stability of intermediates. That will be based on all these effects. For that, first we will individually learn all these effects, all the exceptions, everything based on this. After that, we'll learn the order of stability, right? Like which will be more priority, which will be given less priority. Then we will learn stability of intermediates, acidity and basicity. And based on acidity and basicity, why we are learning all these effects? Because we want to answer acidity and basicity. And based on that, 3 to 4 questions also can be asked directly in your exam. Just based on acidity and basicity. For that, all these lectures are important. Even if you miss one single lecture, that means whole thing is wasted. So next 5 lectures are going to be very important, right? Okay. So now let's understand inductive effect, right? So guys, what is inductive effect? Firstly, it is a permanent effect, right? It is not depending upon any external factor. It does not require any external factor to motivate it and then it will displace the electron. Nothing like that will happen, right? Relative effect with reference to CH. Now every single point I'll teach you with the help of example, right? So relative effect with reference to CH. Now just like in electrochemistry, we studied that with respect to standard hydrogen electron, other electrode potential will be what, right? Similarly, we'll discuss that reference is CH bond, right? Reference is CH bond. Now taking CH bond as the reference, we'll talk about how these effects are going to change, right? So there is one electron donating and one electron withdrawing. Electron donating is who is donating the electron. Electron withdrawing is who is pulling the electrons towards itself, right? Donating means to donate, withdrawing means to withdraw, right? So when you have electron withdrawing, let's say this is CH, this is CH. Now from C and H perspective, we know that carbon is more electronegative. Let's say the electrons are over here, right? So let's say I am writing the electrons like this. I am writing the electrons like this here. This is first and this is the second electron, right? Now what is happening? The same electrons, when you have electron withdrawing, now electrons were here, now you have replaced this with electron withdrawing group. So it is pulling the electron towards itself. It is pulling the electron towards itself. So now the electrons are present here, right? So with respect to CH, this is the difference that you have, right? So that's how it is studied with respect to CH. They will not ask you any numerical based on that. It is just that so you understand these points. These points are given in really good books of organic chemistry, right? So I know you don't have that much time to study all these books. So that's why I have just conclusion of everything that is there, right? Okay. So now if you see, here the electrons are here, right? Now you have electron donating group. Donating means who is donating the electron, like is pushing the electrons here, right? So the electrons are pushed over here. So the electrons are pushed over here. Now this change is the change that is due to the inductive effect, right? This change is due to the inductive effect of electron withdrawing group or electron donating group. Both will show inductive effect, right? Then inductive effect Exactly what is the definition? The definition is, it is a permanent effect, yes, where displacement or distortion of sigma electron. First thing is here sigma electrons are involved, pi electrons are not involved, right? Due to electron, so what is the reason? Due to electronegativity differences as compared to CH bond. So inductive effect is arising because of the electronegativity difference, right, as compared to CH. We are comparing it with CH bond, right? That is why it is arising. Now see, all these things are okayish, but displacement, you understood that I have shown you here that this is the displacement of electron. This particular delta x is the displacement of electrons, right? But ma'am, what do you mean by distortion? Is it the same thing? Let's understand what is the meaning of distortion. So, if you understand this with the perspective of clouds, right, that we have discussed in chemical bonding. So, here it is symmetrical, so we can say there is no electronegativity difference. So, the cloud, electron cloud will be like this. But in this case, the electron cloud will be like this. It will be like this, here it will be less, and here because this is actually not coming out to be same, wait a minute, let me just show you that. Here it will come out to be like this. Why? Because this is highly electronegative, halogen is electronegative, right? So it will pull the electron cloud towards itself. So when you write it in this way, we say displacement. When you write it this way, we'll say displacement of electrons, right? But in reality, what is happening? Distortion. That means the electron cloud is getting distorted to the more electronegative element, and because of that, this inductive effect is arising, right? Okay. Yes. Yes, everybody. Yes. Am I fast? Am I fast? Right? Am I fast? Everybody, tell me. If I am fast, then I'll just slow down. Right? Yes, Ujjwal, Abhinav, Deepan, Varsha. Yes. Tell me. If this pace is fast, then I'll just slow down. I thought I was teaching on a slight slow. Tell me that. Waiting for your answers in the chat box. Right? Yes, at 8, no, today at 8 p.m. you don't have class. Like my class is not there. Wait a minute. My class is tomorrow. Yeah, today at 8 p.m. you have mathematics class. Okay? Maths class. Achha, timing is fast. I was like, I was not teaching fast. Timing fast. But what to do? Exam is near now, so you also have to work hard, right? So that's why you have like continuous classes, right? Okay. So that is the distortion of electron cloud, right? Because of which inductive effect is arising. Now tell me which of the following is correct. What is inductive effect? 1, 2, 3, 4. Spam it in the chat box. Which of the following is correct? Ma'am, you can increase your speed. Okay, I'll increase my speed. Now tell me which is inductive effect. Distortion of pi. Pi is definitely not true. Sigma, yes, yes. Distortion, delocalization, no. Delocalization we will study in resonance, right? So answer will be distortion of sigma electrons is the correct answer here, right? Now next factor is that this effect is distance dependent, right? It depends. For example, you are very sad and you want to talk to your friend, right? If your friend is very near to you, right, then you can visit them. If your friend is very far, you won't be able to visit them. Simple. Same logic, right? So here, in the distance, according to distance, for example, this is electron withdrawing, right? And this is electron donating, right? So here, it is withdrawing, so it will be, this is minus, so it will be positive. It will be small, it will be even smaller, it will be even smaller, it will be even smaller, right? Here it will be minus, 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 minus and very small. So that means as we go away from that electron donating or withdrawing group, its effect decreases with the distance, right? Okay. And now next point is that it introduces polarity in a compound due to electron donating or withdrawing group. Otherwise, it was non-polar, right? So, if you have a non-polar compound, is it polar compound? No, ma'am, it's a non-polar compound. If I replace one hydrogen with halogen, if I replace one hydrogen with halogen, now what you will have? It will be a polar molecule because of this electronegative effect, right? So that is why inductive effect introduces the polarity in a non-polar molecule, right? Okay. Now, inductive effect, other properties are that it is unidirectional, right? As you can see, movement of electron is happening on only one side, either on this side or on that side. It depends upon whether you have electron donating or electron withdrawing. If you can see this here, it is moving on one side, either this side or this side. It depends upon whether you have electron donating or electron withdrawing. Second is it is irreversible. It's permanent, so that's why it is irreversible, right? Third is no leaving or delocalization. Electrons are not leaving here. It's not like you have this pi electron and it is being leaving. No, it is just in the same bond, it is getting displaced to the more electronegative position, right? Okay. Next is different groups cause polarity to different extent. Now, it's not like all the groups will have same polarity. Different group will cause different polarities, right? Okay, so we are going to discuss about those tables also, increasing, decreasing order of polarity also, right? So first is you have two types of effect. One is plus I, other is minus I. So plus I effect is where you donate the electrons, right? So it is electron donating inductive effect, that is EDG, electron donating group. And this is minus, that is electron withdrawing group. That is withdrawing the electron, one is donating the electron, right? Let's see. If you talk about plus I effect, plus I means donation. Now donation will be given more by the person who has like more money, right? Even if a person who wants to donate and they don't have enough money to donate, they won't be able to do that, right? So anion has more electrons, definitely, as compared to neutral, so that's why it is able to donate more, right? So anion is more as compared to neutral. Then branching is directly proportional to plus I effect. That means if you have this CH3, this is CH3, this is CH3, right? Now a methyl group is plus I effect, okay? So if you have a carbocation here, it will donate, donate and donate. If you have a compound which is only having 2 CH3, branching is less, donation is less. If you have a carbon which is having only 1 CH3, branching is less, donation is less. So more is the branching, more is the plus I effect, because more methyl groups will be there, right? Okay. If branching is same, let's say branching is same, in that case what you will do? For example, you have CH3, CH2, C positive, and you have CH3, CH positive. In this case, they both are primary. In this case, if you see, both are primary. This is primary and that is also primary, right? In this case, both are primary. But here what we will do, that more the number of carbons, more will be the plus effect. Here you have 2 carbons and here you have only 1 carbon. I am not counting the carbon which has the charge, okay? So more the number of carbons, more will be the plus I effect, right? More branching is same, number of carbon atom is directly proportional to the plus I. This is very important, right? And we will apply all of this just now, okay? See, this is the order of plus I effect. If you see, anions are more as compared to neutral, yes. Out of that, CH2 negative, then NH2, then O negative, right? Why? Because of electronegativity. Because O negative is more electronegative as compared to nitrogen, right? See, electronegativity order is oxygen, then nitrogen, then carbon. So donation order will be opposite. So carbon, nitrogen and then oxygen. Because the one who is more clever, who has money, right? There are some people out there who have money, right? Can't you see that? I don't want to comment on that, but still, right, we can see that in Nepal what is happening, right? So why? Because some people had money, right, but still they are not able to donate to the public, right, the middle class people out there, right? So that is why they have money, but they don't want to donate because they are very clever, right? Similarly, this oxygen had money, but it doesn't want to donate because it is very, very clever, right? Then after anions, you will have neutral, more branching, less branching, same number of carbon, but more the branching is same, more carbon is more plus I effect. Then this one is very important, that if you talk about hydrogen, deuterium and tritium, right? Tritium has more as compared to deuterium, then you will have H1, right? That is hydrogen 1. Okay, these are the isotopes of hydrogen. These are the isotopes of hydrogen. Okay, that is the plus I effect. Now we are going to apply plus I effect. Now the game is going to be very interesting, guys. Okay, the game is going to be very interesting now, right? Okay. Okay. Yes, very good. TDH. Beta, please focus on what I am teaching you right now. Okay, please do that. Acha, now let's see this here, let's see this here, let's see this here, bitcho. Okay, if you have any like these kind of questions, just put it in the comment section or on the Telegram channel, right? That will be more beneficial so that I can answer you, right, in detail. Okay, so let's focus here, guys. This you have to tell the plus I effect order, right? So we know that tritium is more as compared to deuterium as compared to hydrogen. So answer will be this, isn't it? Answer will be this, right? Answer will be this. So CH3, CD3 and CT3. Should I give you ABCD, ABCD? Then you can answer. Yes, everybody. So if you say this is A, this is B, this is C and this is D, in that case, what will be the answer? This is deuterium has more plus I as compared to hydrogen. So more the number of deuterium, more will be the plus I, right? So it will be DCBA, DCBA, okay? So next full lecture is going to be with examples only. Firstly, I will give you examples of plus I, then minus I, then carbon ion, carbocation, then we will talk about acidity, same with examples. So I want you guys to be fully prepared to answer me, right? Okay, everybody, ready for the challenge? Yes, who is up for that? Who is up for that? Beta, if you don't try to solve yourself, then there is no use of watching the lecture, right? Try to solve it yourself. Even if you are wrong, it's okay. But you should try, okay? At least try to solve yourself. Okay, that is done. Okay, what about this one? What about this one? This one is very interesting. This one is very extremely interesting. So let's see this, okay? What we are going to see here. Here, tell me one thing. This is A and this is B. Tell me what kind of donation will happen. Will electrons go from nitrogen to carbon or from carbon to nitrogen? Or from carbon to nitrogen? Confusion, I will tell you. Electronegativity of nitrogen is more than carbon and hybridization is sp here and this is sp2, not sp2, in fact it is sp3, right? This is sp3, sp, right? And we know that if you talk about the hybridization, sp has more hybridization as compared to sp3, right? Electronegativity of sp is greater than sp2 is greater than sp3, right? Okay, you can write it this way also, that I have told you in chemical bonding. So that's why I told you that chemical bonding before GOC is mandatory. C2N, C2N, C2N. Okay, so you're saying C2N. because of S character is high. Very good. The donation will be from like from end. No. Why are you saying you're giving the right answer but you're answering it wrong? Achha, who is telling it? Because of S character? A. Achha, A. Very good. So according to electronegativity, if you see, nitrogen is more, so nitrogen will pull. So that means according to electronegativity, that nitrogen is more as compared to carbon. It should be this. According to this, Sp is greater than Sp3, so it should be this. But here hybridization will dominates, and hence the answer is A is the correct answer. Okay, hence the answer is A is the correct answer. You have to see all the factors that are there, right? So very good, Abhinav, you have answered it correctly. Very good, right? Okay, yes. So next is minus I effect. Let's talk about minus I effect, guys. This is a big chart of minus I effect. Take a screenshot of this one, everybody. Take a screenshot of this one because I am going to show you one by one all these things, right? So firstly, you have a cation which wants to accept the electron. Then you will have all the neutrals, right? Okay. Then you will have N positive F3, then NR3, NH3, NO2, SO3H, CN, CHO, COH, and all the halogens. Then O, that means OC2, C6H5, COH, OR, COR, SH, SR. Out of these, there are some very interesting points, right? I'll tell you. This one is quite interesting. This one they can ask you. Individually also they can ask you this thing, right? And if you see, OR is greater than OH, right? This thing here and this one also, right? I'll tell you why I have marked all these things. Okay, let's see why I have marked this thing, right? Let's see. So guys, if you see this here, this is NH3, this is NH2R, this is NHR2, right? If you see this here, we are discussing the minus I effect, right? We know that R is donating electron, this is donating the electron, this is donating the electron, right? So plus I effect of, according to plus I effect, this will have maximum, then this, then this. And according to minus I effect will be opposite of plus I. So minus I effect will be, if this has greatest plus I, so this will have least minus I. So this should be the correct thing, right? After this, if I draw NR3 positive, right, which will have, let's say this is N, this is R, this is R, this is R, this is positive, which will have 3 alkyl groups, right? So its plus I has to be maximum because it has 3 alkyl groups, right? So its minus I has to be least, right? Its minus I should be least. That means in this perspective, I can say that it means NH3 positive should have greater minus I effect as compared to NR3, right? But what is written here? NR3 is greater than NH3. That means either this is wrong or our logic is wrong, right? Something is fishy there, okay? Let's see that. Something is not right. Some exception is happening here, right? Let's talk about that. This is not correct, right? Why? This is greater, this is true, but why? The question is why? Why it is so? Let's draw the diagrams, okay? Let's draw the diagram firstly. This is NR3 positive, this is NH3 positive. If you see from the diagrams, right, this is a very bulky group, this is a bulky group, this is a bulky group, right? Bulky group means it will have repulsions will increase, repulsion more means bond angle will increase. I told you that more the Oh God. Just give me a second, guys. Ouch. Oops. Oof. I have some weird pain going on in my legs. So that's why I'm not able to stand properly. But chalo, I'll just stand on one leg. Just give me a second. Okay. Chalo, I'll stand like that. I'll move less. Okay. So repulsions are more, right? Yes. Repulsions more, that means bond angle will be more. So more the repulsions, more will be the bond angle. Bond angle, we know that it is directly proportional to electron negativity. That means S character. Yes. So bond angle more means electron negativity will be more here. If here electron negativity is more, that means minus I effect will be more here. So that is why Nr3 positive has more minus I effect as compared to NH3 positive. Right? Okay. Ma'am, are you alright? I don't know, yaar, am I alright or not? There is some weird, what is that called? Sciatica pain. I have never heard of that name also. Something is happening with my leg because, you know, standing for long hours. So that is the repercussions of teaching, right? Sometimes your throat is not well, sometimes your leg is not fine, but chalo, I'll somehow manage, right? Okay. Okay. Yes. Now if you see, let's see the minus I effect here, right? So if you see this, what I'll do now, I'll just keep it here so that I have to move less, right? I'll move less. And I think by that I can complete this lecture, right, by moving less. So minus I effect it is, and these are the two things that we have observed, that OR is greater than OH and SH is greater than SR. These are very, very important. So mark it important. Usually students get confused here, right? Then you have, if you talk about FOH or NH2, because electronegativity of fluorine is greater than oxygen is greater than nitrogen, that is the reason F has greater plus minus I effect as compared to OH as compared to NH2, right? These are all there in your order. If you see, it is there in the order also, right? So why it is so, that I have already told you, right? Okay, yes everybody. Okay, now tell me about this one. This is A, this is B, and this is C. This is A, B, C. Just give me a second. Okay, I'll just take, thoda sa I'll take Sahara, right? Yes. Okay, now it's better. Yes. This is ABC. I think your, this is not coming in between the blackboard, right? Yes, it is not coming, right? So now guys, tell me about it. Tell me about it. Thank you so much, right? Acha, now it is not visible, then what to do? You know what I'll do? I'll just sit here, I'll give you this particular compound, and then I'll see how many of you answer, right? Beech mein I'll sit a little bit, okay? Guys, my leg is not fine, so I'll sit a little bit in between, right? And then by the time you answer, then I'll again tell you, right? So focus on my voice more. So if you have CN, CH, this and this, if you talk about this, this will have sp3, this will be sp2, and this will be sp. Now more the sp has more minus electronegativity, so it will be like this, because electronegativity is in the order sp, sp2, then you have sp3. So that's why the answer will be A, B, C is the correct answer here, right? Okay. Next is this one. Now hybridization is same, right? Hybridization is same, but this one is oxygen, this is nitrogen, this is carbon. So more is the electronegativity, less is the, see, more electronegativity means they don't want to donate, right? So more is the electronegativity, less will be the minus I effect. So answer will be, this one is the correct answer here, right? Okay, great. Okay, yes. Now what about this one? What about this one? This is regarding a group, that is group number 16. It is OH2 positive, SH2 positive, SEH2 positive, TEH2 positive, POH2. This is from group number 16. Group number 16. Group number 16, guys. Tell me about it. Group number 16, everybody. Group number 16. So, if you see down the group, what happens? Down the group, size increases, electronegativity decreases, right? Because down the group size is increasing, right? So size is less here, then it is increasing. Charge is same, right? So that means the need to have, this is more electronegative. It wants to have electron. It is like I am electronegative, my size is also small. So that's why I would love to have electrons, right? So that's why minus I effect is maximum. Wait a minute, in last, here I have opposite now. Oops, I just wrote the order of plus I, am so sorry. Yes. So it is minus I, electronegativity is more, that means minus I will be more. I just wrote the order of plus I, right? Okay. What about this one? Down the group, what is happening? Down the group, what is happening? Electronegativity is decreasing. That is why the order will be this one. The order will be this one, because down the group electronegativity decreases, so the minus I effect is also going to decrease down the group, right? Okay, right? Now let's talk about carbocation stability, right? Okay, that's what you were thinking. Yeah, I was thinking about my pain, so that's why I wrote it wrong. Okay, so now let's talk about carbocation stability. So a very simple thing I will tell you about carbocation stability, right? See guys, this is a carbocation. Understand one thing, this is a carbocation. In a carbocation, if you are donating the electron, right, or you are withdrawing the electron, let's see what happens. Now bacha, you will take carbocation as money. Tell me, if someone is donating money to you, you will feel happy or sad? If someone is donating money, you will feel happy, or you will be like, oh, he has given money to him, so sad about it. I don't need money, why are you giving me money? Your parents have given you, let's take this 1,000 rupees and enjoy. Today you can eat whatever you want to eat. Enjoy with your friends. You're like, no, I'm literally crying. Why they have given me money, right? So you'll feel happy, right? You'll feel happy. So similarly, carbocation is getting money. It is electron deficient. It is getting money. So it is very happy. So he is smiling, more stable. And if someone who already is poor, already is electron deficient, you are taking money from them. You're like, I'll take money, I'll take money. They're like, I already have no money. Why are you taking money from me? Right? So in this case, this will become very sad, very unstable, right? So that means carbocation stability will increase. This is nothing but this is plus I, this is minus I. Carbocation stability will increase with plus I effect, right? Plus I effect stability will increase, minus I effect stability will decrease, right? Okay. Yes, everybody, hooray, yes, happy, yes. So, this is what you have to remember. Just remember, carbocation means money. Carbocation means money. So, more money, more happiness, right? So, plus I effect increases the stability of carbocation only. I am not talking about carbon ion here, right? So let's talk about this one, right? So this is the first question and this is the second question. Firstly, answer me about first and then answer me second. Okay, take your time and answer, okay, so that I can also get time to relax little bit, right? So in the first case, you have that both are primary, right? But one is giving you, A is having more number of carbons. So more number of carbon means more plus I effect, right? More number of carbon means more plus I effect. This will have less plus I effect. Both are showing plus I effect. So this will have more plus I effect. More the plus I effect, more the money, more is happiness. So here this carbocation is more stable. So A is more stable than B, right? What about this one? What about this one? Here you have fluorine CH2, CH2. Here this is chlorine and this is fluorine, right? So you have to see both are showing minus I. This is also showing you minus I. Minus I effect, more the minus I effect, more will be sadness. More the minus I effect, more will be sadness, because fluorine is more, oops, I don't know what is happening today. So fluorine is more electronegative as compared to chlorine. That is the reason fluorine will show more minus I effect. So more is the minus I effect, more is the minus I effect, less will be the happiness. He will be sad that why you are taking money from me. So B is more stable as compared to A. B is more stable as compared to A. In the second case, very good, very good, very good. So what about this one? A, B and C. A, B and C. Shabash everybody in the chat box. Try to answer yourself. Fluorine, chlorine and iodine you have. Fluorine has more minus I effect. Fluorine has more minus I effect. Okay, I'll just come to this place so that you can see me as well. Now I think I am visible also, right? Okay. Will that work? Will you have patience with me? Okay. Tell me. You can see me, you can see this also. Even my leg is also relaxed. And I am also teaching. So happy? Cool na? Okay. Like my kids are also jugadi like me. So this is A, B and C. Fluorine is having maximum minus I effect, less and less. So more is the minus I effect, more sadness will be there. More is the minus I effect. It has maximum minus I effect. It has minus I, it has minus I, it has minus I. More the minus I, more minus I, instability will increase. So here A will be least stable. Answer will be CBA. Answer will be CBA. Right? Okay, answer will be CBA. Isn't it the correct answer? Yes. Now let's see this one. This one is very interesting, guys. Very interesting. I have given you the hint there. Minus I effect is shown by both of them. Minus I effect is shown by this one also and this one also. Both are showing minus I effect, right? But if you see the distance variates, okay, and inductive effect is dependent upon the distance. So if you see, this is at more distance, this is at less distance. So now you have to see which will dominate here, right? Okay, right? We are jugadu because we are engineers, right? So here it is both. See, we know that fluorine is more electronegative as compared to that. If I only focus on fluorine, I will say that B is more stable because here it is less sadness, it is more electronegative, so more minus I. But in this case, distance will dominate. Okay, distance will dominate here. Distance dominates means what? Distance will dominate in this case. right? That means here you have less distance. That means the effect of minus I will be more here, right? The effect of, for example, there is your enemy who is staying far away from you, right? So your enemy who is staying far away from you will have less effect on you, on the enemy who is staying just near to you, right? So that's why chlorine will have more, chlorine, no doubt it is a weaker minus I group, but because of distance it dominates, and that's why this group will be more stable as compared to this. Okay, A is more stable as compared to B, right? Okay, yes. So now let's talk about next one. This is A and this is B. Now understand one thing. The distance is same. Here you have strong group, here you have two weak group. This is showing minus I, that is also showing minus I. Both are showing minus I, right? This is also showing minus I. But I am telling you that weak multiple group is greater than strong single. Weak multiple group is stronger than single strong, right? So even though fluorine is strong, but it is single, right? They are in group, so group is more dominating. So that's why this will have more power and this will show minus I effect in more extent, so it will make it more destabilized. So answer will be, this is the correct answer. Tell me, is that clear? A is greater than B? Right, everybody? Understood? Yes. Shall I move to the next one? Yes. And here also you can understand that distance always dominates multiple groups. So if you, let's say you have let's say you have this compound, here it is 1 chlorine and here it is 2 chlorines. So if you have to choose between distance and multiple groups, then what you will choose? What you will choose? Distance or multiple groups? You will choose multiple groups. Distance. So even though they are two, but they are far away, this is near, so this will have more minus I effect. So here stability will be, this will be more stable, this is B, let's say this is A. So B is more stable as compared to A. Okay? Right, everybody? Right, everybody? Understood? Yes, students, tell me if that is clear. Right? Okay? Yes. Now let's talk about the next one. Let's talk about this one. I think this one you will be easily able to answer. Right? This is A, let's say this is B and this is C. Okay? It is CH3, CD3, CT3. What about this one, everybody? CH3, CD3. This has maximum, tritium is more as compared to this. This is a plus I effect order, right? This is a plus I effect order. So I can say if this is the order of plus I, if this is the order of plus I, then in that case, if this is the order of plus I, then in that case, this will, the distance is same. This will show maximum donation. So this will make it maximum stable. So CBA. Understood, everybody? CBA. Got it, everybody? In the chat box, do let me know. Do let me know if you have understood that or not. Okay. Yes. Why it is so? Because of the plus I order. Now, this is A, this is B, and this is C. Try to answer this. Try to answer this. Minus I effect of, I am giving you hint here, minus I effect of NO2 is greater than Cl. Okay. Minus I effect of NO2 is greater than Cl. Try to answer this. Shabash, everybody. Try to answer this. Try to answer this. This is also showing minus I. This is also 2 are showing minus I, minus I, minus I. At the same time, this is also showing minus I. So if you see that here, distance is same. So multiple group is the winner firstly, right? Multiple groups are greater than single. So that means this will show maximum minus I. Minus I means D stability in case of carbon ion. So B will be least stable. What about A and C? What about A and C, everybody? What about A and C? What about A and C? Shabash everyone in the chat box. What about A and C here? Yes. C, B, A you have given least. Why? Firstly, just focus on multiple. Multiple, it is maximum. Just focus here firstly that no matter it's weak or strong, this will show maximum multiplicity. It's always DMS. Firstly, distance dominates. Distance is same, so it will be multiple group will dominate as compared to single. So DMS, distance, multiple groups, then single group. Okay, that's how you to remember it. Right, so this will have maximum minus I effect, it will destabilize it to maximum extent. Then this and this, we know that NO2 has greater minus I, so it will destabilize it, so it will be A and here it will be C. Okay, so it is CAB, CAB, right, it is CAB. Clear everybody, right? Okay, tell me bacha if that is clear, how it is CAB. If there is any problem, write it down in the chat box. I can see your chats from here, right? If it is not clear, write it down in the chat box, right? Write it down in the chat box if that is not clear to you, right everybody? So what we have, these three things, always remember DMS. What I am saying, always remember DMS. Distance, multiplicity, then single, right? So distance is same, then focus on multiplicity. This will have the maximum minus I, so minimum stability. Out of this and this, NO2 is more minus I, so it will show you less stability as compared to C, so answer is CAB, right? Okay. Okay, once again also I have taught, now is that clear, right? Okay. I am stable, I am unstable right now. Okay, yes. So, wait a minute, why CBA? Wait a minute. NO2 is more, na? Let me just see that. NO2 has minus, more that effect. Wait a minute. Let me just verify this. B, right? Out of A and C, this has minus effect more, then it will be less stable. So CAB. CBA. No, answer will be this only, okay? So this you can delete, okay? Yes. Yes, okay? Chalo. Now let's talk about this one, A, B, C and D. Let's see if we can answer this or not. What we will focus on firstly, we'll see the distance. Is there any compound which has like more distance? No, these three have same distance. So I'll compare this. And out of these three, this is multiple, right? This is multiple, right? These are single. So remember DMS. First you will see distance. Distance, these three are winning here, right? And for multiplicity, this is winning. That means the minus I effect of this is going to be maximum here. So it is least stable, that is B, right? Okay, that is B. And after that, what you will have? A and C. So in A, what you have? A minus I effect is more. So it will be less stable. So it will be A here. Then you will have C. And D, because the distance is more, minus I effect will be less, so it is maximum stable. Just remember that minus I effect is decreasing the stability. Just remember that minus I effect is decreasing the stability. Okay, DCAB. Okay, what is that? DCAB, right? Okay, right? DC, D is maximum, then you have C, right? Then you have A, then you have B, right? Okay, so answer will be DCAB is the correct answer here, right? Now if you see ABC here, what is the correct answer? If you see this, bacha, this is, and this you have. This is minus I and this is minus I. Yes, everybody. If you see this here, if you see, this is the thing that you need to see. Here Cn will lie somewhere here, that is Cn, and this is NO2. So NO2 has more minus I effect, so it will destabilize the carbocation. Okay, so it will destabilize the carbocation. So in that case, what you will do? This will destabilize, so that means this will be minimum stability, right? Here nothing is happening, so no one is there to destabilize it. He is very happy, so it is very stable, right? C, it is there to destabilize, but what is happening here? It is there to destabilize, but this Cn has less minus I effect, so it will be C. So ACB is the correct answer here. Okay, everybody, are you able to understand that? Let me know in the chat box if there is any problem. Guys, I am in pain right now. I know how I am standing, right? Otherwise, you have never seen me sitting and teaching you, right? So that means if I am teaching you, na, right, that means something very important is there, right? Otherwise, I would have cancelled the class, right? So that's why I am saying if you have any problem, I am here to tell you only, to answer your queries only. I am here. Okay. So next is ACB, na? Yes. Okay. Yes. Now what about this one? A, B, C, D you have. Achha, who will answer? You will answer now. You will remember DMS. Just remember DMS. Firstly, see the distance here. Firstly, bacha, see the distance here. All of them are minus I. This is minus I, that is minus I, that is minus I. Here you have no effect. So if there is something which has no minus I or plus I effect, this has just plus I effect of this carbon chain, that means C is going to be maximum stability. So C is out of the equation only. C is out of the equation, guys. C is out of this equation. Why? Because it does not have any minus I effect, right? It has just this carbon chain. So it is out of this equation. Now you have to choose between A, B and D, which will definitely be less stable as compared to C, because they have minus I effect, which decreases the stability of carbocation, right? Which decreases the stability of carbocation. If you see this here, this is NO2, this is NO2, this is Br. Now guys, see this thing. Distance, firstly I will see. This has least distance, so it will show maximum minus I. So it will be least stable. Out of this and this has intermediate distance, so it will be B. This has maximum distance, so the capability of this minus I will be very less, so it will be A. What I told you, distance dominates, right? If distance is less, you will not see that which one is more minus I, which one has less minus I. So answer is CABD. Very good. Answer is CABD. Very good, very good. I'm very happy that you guys are able to solve this, right? CABD is the correct answer. Next is this one. Let's see who will solve this. A, B and C. A, B and C. These, one of my favorite lectures are GOC only. So A, B, C. If you see A, B, C, A, B, C. So if you see, it is 3 degree, right? It is 2 degree and that is 1 degree. So 3 degree is more stable as compared to 2 degree as compared to 1 degree. So answer is simple. CBA is the correct answer here. Okay, CBA is the correct answer here. Very good, very interesting, very interesting. Okay, now let's see this one. A, B and C. Okay, A, B and C. Now let's see what is going to happen here. Yes, everybody, A, B, C. Now you have to see the minus I order here, right? The minus I order here, right? Minus I order of NO2OH and OCH3. NO2 is maximum, then you have OH here, then you have OCH3 will be somewhere here. In the middle it should be OR. Okay? So NO2, OR and OH you have the order, right? So let's see this. Let's see what is going to be the correct answer according to this order here. According to this order, what is going to be the correct answer, right? So what is going to be the correct answer here according to this order, right? According to this order, beta, if you see, NO2 is maximum minus I, distance is same, right? Then you have OCH3, then you have OH, right? Okay. So now in this case, this has maximum, that means its stability is going to be minimum, right? Because it's a carbocation. So its stability is going to be minimum. So A is least, A is least. Out of C and B, this is more minus I, so its stability will be less, right? And this has minimum minus I, so its stability will be maximum. So B, C, A is the correct answer. Okay? Okay, got it? B, C, A is the correct answer here, right? So, next is based on S character. If you say this is A, this is B and this is C, and I know you can answer this. I know you can answer this, right? Okay? Yes. In the first, that is SP, this is SP2, this is SP3. That is only difference, right? The difference that it has, that this is SP, this is SP2, this is SP3, and more is the SP, more is the minus I effect. So here minus I effect is maximum. So it will destabilize this particular carbocation. So answer is going to be, this is the correct answer here. Okay. More electronegative will decrease the stability of the carbocation. Okay. If we are discussing the stability of carbocation. If let's say they have not written here that answer the stability, if they answer what is the order of minus I effect, then the answer will be this. This is the order of minus I effect and the order of carbocation stability is this much, this one. Okay. So answer is CB, A is the correct answer, right? Okay, yes. Now let's talk about carbon ion. Carbon ion is a negative, which you have on carbon, you have negative. So now when you are donating the electron and when you are withdrawing the electron, what will happen? Right? See, understand one thing. Take it as stress. Tell me one thing. If someone is giving you a lot of stress, this and that they are saying, a lot of stress they are giving you in your head, right? So you will stay away, you will feel unhappy. So when someone is giving you stress, you feel very sad, you feel very unhappy. When someone is giving you, taking away stress from you, that you are talking to your best friend, right? You are talking about this and that, you are very happy. Your brain is relaxing, right? So you are very happy, you are in a stable mode. So what exactly happens? In a carbon ion is not interested in taking the electron, it already is electron rich. So when you give electron to carbon ion, it is unhappy, it is unstable. When you take away electron from a carbon ion, it is stable, right? That means here it is the opposite case, that plus I is going to make it unstable. Minus I is going to increase the stability. It is opposite of that of carbocation, right? That's why you need to see that, right? Okay, yes everybody, do let me know in the chat box if that is clearly understandable to you, so that we can see the questions for carbanion here, right? Okay everyone, got it? Yes. So this is A, B, C. If you see, this is minus I, this is minus I, this is minus I. Now this is entirely different approach that we have done in carbocation. Now minus I will increase the stability. So that means this will be maximum stable. So answer will be A, B, C is the correct answer. Please focus here guys, please focus here. A, B, C is the correct answer here. Okay. Next is this one. Now let's see who will answer me this. Take it in the same form that I told you. Firstly, focus on distance. More the distance, more will be, less the distance, more will be the minus I effect. Then focus on which is more minus I, that will make it stable, right? That will make it more stable. See, this is multiple bonds you have, okay? Two benefits. Firstly, let's talk about distance. Distance is least here. That means minus I effect will be maximum here. That means it is going to have maximum stability, right? Out of these two, they both are at same distance, but this one is more minus I. So it will make it more stable as compared to B. So answer will be ACB is the correct answer here. Okay, yes everybody, just give me a second guys, just give me a second. Yes everybody, so answer is A, C, B is the correct answer here, right? Okay, yes. Next is, again you have three same groups here, the distance is different, right? The distance is different. So let's see who can answer this. The distance is different. Remember DMS, first you will focus on distance. Less is the distance, more is the minus I. And in case of carbanion, more is the minus I, more is the stability. So here maximum stability is for C. Then out of these two, it will be B. Least, like maximum distance is here, so it has minimum minus I. So that means it will be A. So answer is C, B, A is the correct answer here. Okay? Yes? Okay, CBA is the correct answer here. Next is, you have, now let's see who can answer me this one. Let's see who can answer me this one. Again, you have DMS, all of them. DMS, all of them, bacha, DMS, all of them. Focus on distance, distance. These two are at less distance. So, this you can ignore. Firstly, you will choose this or this. Out of these two, you will see maximum minus I. Because same distance, but this is multiple groups, so this will... But guys, this is minus I, this is plus I. This is plus I. This is minus I. So this will be maximum stable. Moreover, it is multiple group, right? So E is giving you plus I. It is from more distance, but still it will make it unstable. So it will be least stable. And here it is minus I, but it is making it stable. So it will be C. So it will be BCA. Plus I, you will write it in the end. That is giving you plus I. So I have written it in the end because plus I is going to give you least stability. Plus I, guys, it is going to give you least stability in case of carbon ion. Right? Okay? Yes, everybody? Got it? Yes, students? So let's see this one. Let's see this one. I don't know how many, very few questions we are left with. Right? Okay? Let's see if you can answer this. Let's see. This is minus I. This is plus I. And it has no effect. I think this though you will definitely answer. Yes, Abhinav, Dipash, Surya, then Patel. Yes, Anjali. Very good, everybody. Answer this. Answer this. Minus I is going to increase the stability. Plus I is going to decrease the stability. Minus I will increase the stability. Plus I is going to decrease the stability. Very good, Surya, Dipas, Anjali. Very good. Very good. So if you see this here, this is actually minus I, it will make it most stable. Then in the middle it will be A and B will make it least stable because of plus I. So answer will be CAB, CAB is the correct answer. Okay. CAB is the correct answer here. Very good. Right. Okay. Next, guys, tritium. Plus I effect of tritium is T, then D, then H. Now tell me what is the correct answer. TDH is the plus I effect. TDH is the plus I effect. Right? Okay. Yes. TDH is the plus I effect. So tritium will show you maximum plus I effect. Right? Maximum plus I effect here. Tritium will show you maximum plus I, so it will make it least stable. So answer will be CBA. Tell me if that is clear. CBA is the correct answer here. If that is clear, very good, very good, very good, everybody. Very good. Awesome, 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 awesome. Now let's understand about acidity. Now firstly tell me no. Yes. Thank you so much, Mutha. Thank you so much. That means a lot to me. That means a lot. Right? Yes, definitely. Right? Vedantu is the best. Right? Okay. Yes. So now tell me one thing, guys, that are you clear on like how to answer plus I, minus I based on carbon ion, carbocation, how you will understand the stability based on minus I and plus I. I have not told you other factors now. We are just doing questions of inductive. Then others will do, we'll add all of them after this. Right? Awesome. Yes. Okay. Now see, what are the applications of inductive effect, right? Applications is, now ma'am, what is this Barhi? Barhi beta, this is how I tell my students to learn this. Barhi is back bonding, that we'll understand in next class. Resonance, aromaticity, hyperconjugation, inductive. So the effect that we have studied now is actually on the least priority side. Okay. So one by one we'll understand all these effects. Now then after the combination of all these effects we'll understand how stability of intermediates is given. That you will understand after 3-4 lectures. We'll apply this Barhi. Okay. Then acidity and basic strength also will tell based on this one. Now let's understand, ma'am, how acidity and basicity will tell based on this one. Okay. Let's see. Now students, tell me one thing. This is HA, right? it give rise to H positive and A negative. Now tell me one thing. If I tell you after cracking IIT, you will get nothing. Will you try to do that? Tell me one thing. If I tell you, right? If I tell you that after cracking IIT, you are not going to get a good package, no salary will be there, nothing will be there. Will there be any motivation to crack IIT? Will there be any motivation if I tell you that even after getting your dream college, you will not have anything in life, right? You will not have any motivation, right? Zero motivation, right? So that means you will do hard work only if you know that the results will be there somewhere, right? Only then you will go in that direction, right? Then after getting that thing, I'll have something in life. That means if I tell this acid that after losing H positive, you will have a stable carbon ion, then this will be a good acid, right? Then it would want to lose H positive, right? So this will only would want to lose H positive if A negative is stable. That means more is the stability of carbon ion, better will be the acid. So whenever they ask you like which is a good acid, acidity, basicity is see, acidity is inversely proportional to basicity. But see, like in the end, the last lecture will be based on acidity, basicity. Today I am just giving you introduction of that, right? So it is not done. It will be a proper lecture for acidity, basicity. I am just giving you starting introduction where only inductive effect will be applied, okay? But in the end, we will apply all the effects and then we will calculate. That is the level that they ask you. But sometimes simple questions are also, I'll also show you in 2024, they have asked very simple questions based on GOC. Not very long, 2024, right? So that means to have a good acid, right? It needs to have a stable carbon ion. And we have understood the stability of carbon ion. So all you need to see is stability of carbon ion. More carbon ion is stable, more will be the acidity. Now tell me which one is more stable here. Which one is more stable here, right? Okay. Which one is more stable here? If you see, this is donating the electrons, right? So when to a carbon ion, this is basically we are talking about HCOH and CH3COH, which is a good acid. This we want to know. For that, firstly we will see the anions of that. So this anion, here it is plus I effect, so it is making it unstable. So this is more stable, so that's why this will be a better acid, right? So A is a good acid. That means formic acid is a good acid as compared to acetic acid, okay? As compared to acetic acid, formic acid is a good acid, right? Okay. Then what about this one? This is A, this is B. Guys, where are you all? Where are you all? Chit-chatting. This, hai na? Let's not chit-chat. Focus and tell me the answer. Don't get distracted. Right? Tell me the answer for this one. Yes, everybody? Yes, everybody? Yes. Yes, everybody. So in this case, you have an electron withdrawing group. Minus I it is showing, right? And that is the reason it will make it more stable. So acidity will be more here. So because we are talking about this negative, this is positive. This is negative, this is positive. Oof, so tough to walk, na? Oof. Okay, this is negative, this is positive, negative, positive. You have to talk about this carbon ion. Here because of minus I effect of NO2, this will be more stable because minus I effect increases the stability of carbon ion and hence this is a better acid as compared to A. Right? Okay. Yes, everybody. Next is, this is A, B, C. What about this one? Distance is same. Here multiplicity is same. This is more minus I because this has greater minus I effect. So this will be maximum stable, then you have B and then you have C, right? So answer will be acidity, answer will also be C, B and A is the correct answer here. Okay, right bacha? This is NO2, it is minus I effect, right? So minus I effect in that case is more. So stability of carbon ion will be more, and that is the reason it is CBA is the correct answer here. Okay, okay. Acha, what about this one? This is O negative, this is simple alkyl chain, this is extra CH3. So this is a carbon ion that we are talking about, CO. This is positive, it will lose this. So CO is what we are talking about, right? So O negative, right? It is showing plus I, it is showing maximum plus I, right? So it will make it unstable. B has no effect. C, because of plus I, is also decreasing the stability. So here it will be C and here it will be B. This also shows plus I, this also shows plus I. Plus I effect of, we know that a anionic species is greater than CH3. Right? Okay. So answer will be BCA because this has no effect. These two have plus I effect, and plus I effect of this is more, so this will be less stable, and in between you will have C. So answer is BCA is the correct answer here. What about this one? What about this one? I think this is one of the last questions. 1, 2, yes. Second last question, guys. Second last question. Let's see who will answer this. Okay. Let's see who will answer this. Now I'm waiting for your answers in the chat box. Last 2 questions we have of today's class. Let me see who can answer this, right? Firstly, see the distance. You need to find the stability of carbon ion formed after losing H positive for this acid. For this acid, after losing H positive, what is the carbon ion form, and that carbon ion will have stability or not, that you have to answer. Okay, yes everybody. So if you see this, distance is same in these 3 cases, right? Distance is same in these 3 cases. Distance is same here, Cl, this is NO2, this is Br and I negative. Now in this case what we will see, the distance is same and that is multiple, so that will have maximum minus I, so it will make it maximum stable. So D is going to be a maximum stable anion, so it is going to be most acidic. Then out of Cl and NO2, this has more minus I, this has less minus I. So this will make it more stable as compared to B. And then A, because of the distance, it has least minus I, so it will be unstable. So answer will be DCBA is the correct answer here. Very good, very good, very good, very good. DCBA is the correct answer. Last question of today, right? Then I am going to show you 2 PYQs and that's it, right? Okay. So firstly, see the distance. The distance is minimum here, so that is why it is going to show you maximum minus I, so it is maximum stable, right? This is more distance, less minus I, less stable, even more distance, more gap, less minus I and less stability, so it is CBA is the correct answer here. Okay, got it? Now let's see who will answer me this 2024 question. 2024 question, guys. Let's see who will answer me that. The correct sequence of acidic strength of the following aliphatic acids is what? Very simple question they have asked. Very simple question, everybody. Let's see who can answer me this. Let's see who can answer me this. A, B, C, D, which is the correct answer here, everyone? Which is the correct answer, everyone? right? Okay. Yes. So here if you see, you need to see HCO negative you have CH3COO negative, you have CH3 CH2 CO negative, then you have 3 carbons, CH3 CH2 CH2 COO negative. So more is the carbon chain, more is plus I effect. Plus I effect decreases the stability of carbon ion. So here this will be the answer. HCOH, then CH3COH, then CH3CH2COH, CH3CH2CH2COH. So answer will be B. Very good. Awesome, awesome everyone. B is the correct answer. Very good. Awesome. Right? Very good. If you would have answered it incorrectly, na, I will be very disappointed. Right? Now answer this one. They are saying the ascending acidity order of the following. Beta, acidity of hydrogen means if the, let's say this is carbon, this is hydrogen. If this carbon is very highly electronegative, then the electrons will be more here, right? And this hydrogen will be like, you are not sharing your electrons with me, so I am going, right? If you don't want to share the electrons, I don't want to be with you, right? It's like your friend has a pizza and he's eating the full pizza, he's giving you just one slice, you are like, you don't want to share it with me, it's okay, I'm going, bye-bye, right? So that is the thing here, right? So if the stability, let's say, let's calculate this, this is SP, this is SP2, this is SP3, this is SP3, right? Here you have SP means this is having maximum electronegativity. Oh, I'll just sit only. Okay, so this will have maximum electronegativity, right? So here the pair of electrons will be more towards this one. So it will have maximum acidity. It will be like, you don't want to share, I am going anyway, right? So here it will be less, like electrons will be still towards this side. Here the electrons between C and D, between this and this, because it is having 3 plus I, so the donation will be more here. So that's why it is least and this will be D. So answer, I think it should be A, B, D, C. A, B, D, C. A is the correct answer. Wait a minute. A, B, D, C. Acha. A, B, D, C. It is. So D will be the correct answer here. Okay, that was the opposite order that was written. A, B, D, C. This is the correct answer. So answer will be D is the correct answer. Right? Okay, it says that if hydrogen is like, you are not giving me electron, I am going. Okay, if you see this here, hydrogen is like, you are not giving me electron, I am going. It's like, you are giving me, but you are not giving me that much. It's like, okay, too many electrons, I am so happy, so I will not leave, right? So here it is like, it is sp3, but the electron donation is less, right? Okay, so answer is CDBA, right? But so that we will, Kailash, that will talk about when we will do these functional groups, okay, that is a part of that. And still we have not done all. I am not teaching you full acidity, basicity. There are so many factors that are dependent. There is resonance, there is hyperconjugation, there is aromaticity, right? So many effects, back bonding that will define acidity. I have just shown you few examples which can be answered with just the help of inductive effect. Okay, right? Yes. So that's it about today, and now guys, this is your homework, and take a screenshot of this. Take a screenshot of the homework, everybody. Take a screenshot, and I'll take your class tomorrow, right, at 8 p.m. 8 p.m. I'm saying at 6 p.m. Just if I feel that I will be able to, I don't know, like 70% chances that my leg will be fine and I'll be able to take the class, because tomorrow's lecture is very important, and I'll see, right? Like if my leg is like too much paining, then I will avoid taking the class. I'll see that. Most probably I'll take the class. Even if I am taking by sitting, I'll take, right? Because I don't want to waste your time, right? Okay. So answer this question, right, everybody, in the comment section. And before going, right, again there is a reminder that 4th, 5th, 11th and 12th of October you have MVSAT test. Registration is free. You will get scholarship, 100% scholarship, 150 crore worth scholarship and 2 crore worth prizes you will get, like iPhone, iPads, all these things you will get, right? For that, what you need to do, register yourself into this and give the test in your nearest Vedantu center. You can give the test online as well, but preferable is offline, right? Okay. Yes, everybody. Done. So that's it, guys. I'll see you all in the, now, yes, write down your homework in the comment section, right? Take our test. Yeah, Abhinav, I'll do that. Don't worry, I'll do that. Right? Okay, we'll do that. Right now, I'm just too occupied with the classes that I'm not able to get the time, and my health is also not fine. No, you can see that in what health I'm taking your class, right? So that's why I thought of taking the class, extra class on Monday, but my health was not at all fine. So I thought let's not take extra class, because I was feeling like, if I take this class, maybe I'll have to, cancel the upcoming lecture. So that's why I prioritize these lectures, right? Okay, chal. Okay, so thank you so much, Varsha, Abhinav, Anjali, Sachin, Rohit. Yes, chalo. Now I'll see you all in the next class. Bye bye. Take care. See you all in the next class. Bye bye. And don't forget to write your homework in the comment section. Bye bye. Take care. Bye bye.